Dr. V.V. Kamesh, Professor of Mechanical Engineering, Aditya Engineering College. Today, we would like to know the velocity analysis and acceleration analysis. So, regarding the kinematics of machinery, the various course outcomes are: make use of, at the end of the course, the student will be able to make use of the kinematic links and pairs to form different chains, mechanisms and inversions. And second course outcome is the student will be able to explain different lower pair mechanisms for exact and approximate straight line motions. And the third course outcome is the student will be able to analyze the velocity and acceleration of various links of the mechanisms by using different methods. And the fourth course outcome is the student will be able to develop the cam profiles at various follower motions. And the last course outcome is the student will be able to solve various aspects of the gears and gear trains. And in today's lecture, the velocity acceleration analysis, the various contents are the velocity, motion of link in a machine, determination of velocity diagrams by the graphical method, application of relative velocity method for the 4-bar chain, analysis of slider crank mechanism for displacement velocity, finding the angular acceleration of the links, acceleration of the intermediate and offset points, 4-bar mechanism and slider crank mechanism, Klein's construction, Coriolis component of the acceleration, instantaneous center of rotation, 3 centers inline theorem, graphical method determination of the instantaneous center for 4-bar mechanism. And the various learning outcomes for the first lesson. At the end of this class, the student will be able to construct velocity diagram for the given mechanism. So, these are the various topics that we will discuss now. Construction of the velocity diagram by the relative velocity method, calculation of angular velocity of a link in a mechanism, and calculation of the rubbing velocity of the links, finding the instantaneous center of rotation, construction of acceleration diagram, and calculating 2 components of the acceleration. Now, this is the fundamental thing of constructing a velocity diagram. So, in general, the velocity diagram is also called configuration diagram, because what are the composition of the different links and different joints with the different angles and lengths, that is the configuration. That is why the velocity diagram we will construct, it is also called configuration diagram. And in this, what we learned, analysis of mechanisms is the study of motion and force concerning their different parts. Earlier we learned something about the mechanism. Here the mechanism means it is the composition of links and joints in a defined manner. For these links, how it will behave, how it will generate some force, how much force a link can withstand, these are all the fundamental things in the design process. To get that component, the first thing we need to do is the study of motions, after that forces. And the study of velocity analysis is the first thing. First we will analyze the velocity, what are the different linear velocities and angular velocities, and these velocity analysis will be an input for acceleration analysis. That means velocity diagram is the first step. The output of the velocity diagram, whatever the velocities of the different components, it will be feeding as an input for the acceleration analysis. After finding the acceleration diagram and its analysis of the 2 components of the acceleration, then this acceleration analysis will be the input for force analysis. After the force analysis, then we will go to the actual design of components. So, once we will find how much force is generated at a particular area at the joint or a part of a link or some distance with a particular joint, So, for this force, which material we need to use, what is the thickness of this particular link, and what type of material we need to use, what shape we need to use, all this will come under the design of the components. So, for our purpose starting of the velocity analysis, initially what we need to do is, what is the velocity diagram? A machine or a mechanism is represented as a line diagram. So, in the velocity diagram, even though we are calling a crank is rotating, a connecting rod is there, a piston is there, a cylinder is there, an object is there, but everything will be described as part of a line diagram. That means if two objects are moving, then what we will do? We will create some points. First point, first object. Second point, second object. So it is moving. That means we need not draw any road or bus or car or something. Simply a bus is moving. That means we will take a point and we will make an arrow, that is the vector notation of the moving bus or moving car or moving object or moving person, anyone. All are represented as a line diagram, and this we are calling with another name configuration diagram. That means what is the composition of the actual problem. So, which parts we are having the composition, what type of linkage it is, and which part is moving or which part is giving the input, and what we need to calculate. So, in the velocity analysis of mechanisms, we are having two different methods. One is relative velocity method and second one is instantaneous center method. These two are graphical methods. Earlier we have analytical methods also, but these analytical methods are requiring very high amount of computations. So, there are some angles, there are some length parameters, and there are some equations. There we need to have some derivation part, some objects to be explained in a detailed manner. So much of analytical procedure will be there. There we need to have some differentiation or integration. Like this, some mathematical procedures will be there. So it requires lot of computation. But graphical methods is very easy to understand, very easy to construct, and the last thing is very easy to analyze. So first we will go to the relative velocity method. So what we will do, the relative velocity of two bodies moving in straight lines. So the word itself is giving some indication, relative. Relative means when it is compared with other, relative velocity. That means suppose a body is moving with some velocity. Suppose we are having one bus is moving. Suppose we are calling this is a bus is moving from a origination station with 50 meters per second, right? And what is the velocity of the bus if we ask? Technically speaking, these 50 meters per second is the relative velocity of the bus with reference to the standard static item road. With reference to the road, the velocity of the bus is 50 meters per second. Suppose this is being compared with another object, a car moving with 70 meters per second. Suppose if you are asking what is the relative velocity of the bus with respect to car or with reference to car, this is moving with 50 meters per second, this is moving with 70 meters per second. What is this 70? Relative velocity of the car with reference to road. This is relative velocity of the bus with reference to road. So we are taking the road as the standard item to compare the velocity of the bus and car. So whenever the relative term will come, we are comparing with others. We are comparing with another static body or another moving body. So, if it is compared with the road, it is 50. If it is compared with the road, it is 70. Now, the bus is compared with the car, right? So, the relative velocity will be VBR and VCR difference. So, this is moving with 70, this is moving with 50. That means car is far ahead of the bus. That means the bus is trailing, right? So, in the race, car will be front, bus will be back. That means what is the movement of the bus with reference to the car? It is negative. If it is positive, it is going ahead. If it is negative, it is coming back. That's why the relative velocity of the bus with reference to the car, it will be VBR minus VCR. Then it will be 50 minus 70. Then it is minus 20 meters per second. Suppose we are asking what is the relative velocity of the car with reference to the bus? That means how much additional velocity the car is having over the bus. 70 minus 50, it will be plus 20 meters per second. Like this, the relative velocity of the two bodies moving in the straight lines will be compared now. So, first we will take two bodies that are moving in straight lines, not in the inclined lines. We are taking. So, this is one example for one object. It may be bus, it may be car. This is moving it to VA, and how we are representing in the vector notation, that we will learn in an easy manner. When vector is being taken, it is having some magnitude and in what direction it is. So, magnitude and direction both need to be represented in the diagram. So, the first object A is moving with some velocity VA. Second object B is moving with velocity VB in both in the same direction. Both in the same direction. So, basically speaking, VA greater than VB or VA is equal to VB or VA less than VB. Three conditions will be there. In the first case, we will discuss the VA is more than VB. So, VA greater than VB, right? So, how we will represent first VA? Let us take the VA is greater than VB. VA is equal to some 100 meter per second. This 100 meter per second is represented as OA. That means earlier bus and car, these two objects need to be compared with a standard item. This standard element is O. That means one standard point is being taken as the center, and from the center, this is O. From the O, we are representing the velocity of A and velocity of B. So, from O, what is VA? 100 meter per second. This is to be represented as OA, and this we are calling VAO. And this is one type of notation. If we are having only from the starting point only we are referencing and representing in the equations, it can also be called as VA only. So, the representation of VA is OA and the representation of VB is again OB. This is represented as VBO or VB. So, in the initial case we are representing this is OB. Let us take the VB is something less than VA. So, it is 20 meters per second. So, VB is OB. So, we are combining these two because same parallel lines these are moving and generating from same object, that is O. So what we will do, we will combine these two. So OBA. That means this part is VB 20 meters per second. This part will be the remaining 80 meters per second. OA is representing 100, OB is representing 20. Now the question comes, where is the relative velocity of A with respect to B or B with respect to A? So here A is ahead of B. So the difference OA minus OB, it is representing VAB. That means velocity of A with reference to B. So it is positive because it is ahead. A is ahead of B. That means from measurement, OA is 100, OB is 20. So A is ahead of B by some units. Here it is 80 meters per second. So VAB is 80 meters per second. So, and here the same thing is, we are calling with the name VBA. So, velocity of B with respect to A, how much it is lagging behind? That means minus 80 meter per second. The representation of these elements VAB or VBA, based on the representation, the vector will have the reversal of the direction, and the numerical also will have the reversal. So here we are having the relative velocity of A with respect to the B. It is the vector difference VA minus VB. Just like I told, 100 minus 20. So this is from the representation of the graphical sense OBA, BA. That means this part VAB is represented as OA minus OB. Just like in the ordinary lines and triangles and different diagrams. So this length component. So I need BA. So it is OA minus OB. I will get BA. This BA will be, because we are making the symbol length component. That's why we are making some bar here, OA minus OB. Similarly, we will calculate the relative velocity of B with respect to the A. It will become reversal. So VB minus VA. So VB means OB, VA means OA. So it will be AB bar. Because we are taking the reversal case, VBA. Right? That's why OB minus OA, it will become negative because A is ahead, B is behind.